Hello everyone, myself Shweta Shah and I am your instructor for the subject Microprocessor and Microcontroller. In this subject we have started Unit 2, that is Architecture of Microprocessor 8085 and Microcontroller 8051. In this session we are going to see the architecture of 8085. So in last session we have seen the register array block from the architecture. In this section we are going to see different other sections that are included in the architecture. So this other units are ALU or logical group, then instruction decoder, timing and control, interrupt control and serial IO group. Okay, so first let me see what is the ALU and the logical group. It is consisting of the ALU, accumulator, temporary resistor and the flag resistor. Here ALU that performs the all of the arithmetic and logical operation and stores the result of the arithmetic and logical operation inside the accumulator. Okay, accumulator that we have already learned, that is the general purpose resistor, is of 8-bit. It stores the one of the operand before the arithmetic and logical operation and also stores the result of the operation. Okay, so and it also stores the data during the IO operation, or you can say IO transfer. Okay, so basically this ALU block is consisting of the ALU and accumulator and the temporary resistor and the flag resistor. So the temporary resistor, as we know, that is also of 8-bit, and during the arithmetic and logical operation one of our operand is going to be stored into the temporary resistor and one is in the accumulator. Okay, and for example, if we consider the instruction like add B, in this instruction content of B is added into accumulator and result is going to be stored into accumulator. So first the content of B resistor is going to be transferred into the temporary resistor, and then the addition of the temporary resistor and accumulator is done, and then result is going to be stored into accumulator again. Okay, so this is the kind of operation where you are using the temporary resistor. And flag resistor, as we have already discussed, this is containing the 5 flags like sign, parity, carry, zero and auxiliary carry flag. Okay, so these are the basic 5 flags which we are using, and these flags are set or reset according to the result of ALU. Okay, last performance or last operation, whatever you have done inside the ALU, according to that your result is going to be updated in the flags also. Okay, so this is the basic block of ALU and logical group, which contains ALU, accumulator, temporary resistor and flag resistor, where you are performing all of your arithmetic logical task. Okay, next, so this is your ALU block. This is accumulator, temporary resistor, flag and ALU. This is your ALU block. Okay, next block is the instruction decoder and timing control group. This is like this. This is the instruction decoder and machine cycle encoder, and this is the instruction register. So this instruction decoder group is consisting of the instruction decoder and instruction register. Here the instruction decoder decodes the opcode that you have stored in the instruction register and establish the sequence of events that require to be complete that execution. Okay, and encodes it into and transfer to the timing and control unit to perform the execution of the instruction. Okay, so it will decode the instruction, establish the sequence of events to be followed, encode those events into timing, and it provides this information to the timing and control unit. Okay, so this is the basic task done by the instruction decoder unit. This is your instruction register and this is your instruction decoder and machine cycle encoder unit. It provides the information to the timing and control unit. According to that, timing and control unit will work. Okay, and this in this instruction register you are temporarily storing your instruction before decoding. Then next group is the timing and controller group. So in this timing and controller group, it works as the brain of the CPU for the proper sequence synchronization of all of the operation of the microprocessor, this unit generates all of the timings and control signals that are necessary for the communication between the microprocessor and peripherals. Okay, so this is the timing and control unit that generates your status signals, DMA signals, reset signals, control signals, and all power supply signals and all others. That will be much more clear when we will see the pin diagram. This all are basically pins, and what is the meaning of that pin we will see in that section. Okay, so this is the basically a timing and control unit which provides the timing and controls for all of the tasks. Okay, these are basically a timing and control signals which are generated by this unit and providing each and every time wherever required. Next group is the interrupt control group. This you can consider interrupt as a occurrence of the external disturbance. Whenever some task is going on and some external device requests for some task, then you are interrupted from your original task and you have to provide access to that device or that task. That is known as the interrupt. So whenever your interrupt occurs, your processor has to stop its task and provide service to that interrupt. Okay, and after that providing that service, the processor will return to its normal working. Okay, and this transfer of the control will be performed by special routine that is known as a subroutine, or you can say interrupt service routine, ISR. Here we have basically 5 interrupts that are trap, RST 7.5, RST 6.5, RST 5.5 and INTR. Okay, in response to the INTR, the acknowledged signal is required to be generated, and that is INTA. Okay, if we consider the block diagram, then you can see here this is the interrupt control unit. It has a INTA, RST, INTR, RST 5.5, 6.5, 7.5 and trap. These are the 5 interrupts. These are used by this control unit, and this is INTA, that is your external acknowledgement signal. Okay, for this INTR, general purpose interrupt, you are using this acknowledgement to indicate that this interrupt is generated and that is acknowledged by the processor unit. And the last group is the serial IO control group, where you can the data transfer between D0 to D7 lines in a parallel data bus. But the under condition, it is used as a serial transfer also, and that we can see by using this 2 pins, SID and SOD. Serial data is entered to the SID, that is serial input pin, and that the data is outputted on SOD, that is serial out data. You can transfer the data parallelly, that is possible for D0 to D7, but if you want to transfer data serially, then you have to use this SID and SOD pin, serial input data and serial output data. Okay, so this is your serial control group, where you can serially input the data and serially output the data. Okay, this is the basic architecture, where we have divided whole architecture into 6 parts. That is, your first is your register array or register block. Second is the ALU block, where you have accumulator, temporary register, flip-flops and ALU. Then we have the instruction decoder unit, where we have instruction register and instruction decoder and machine cycle encoder. Then we have the timing and control unit, which provides the different timings and control signals. Then we have the interrupt control unit, where you have different interrupts and the acknowledgement for that interrupt. And lastly, we have the serial input output block, that is serial IO control, with serial input data and serial output data. Okay, here we have with the buffer, we have this address bus and data bus, multiplexed bus, and this is the single bus. Okay, so this is the whole architecture of microprocessor 8085. Okay, so here we are ending our today's session. If you have any query, then you can contact me.